We the best now, ayy.
Good day, good day, good day. Welcome back to our YouTube channel. So if you're new here, welcome. My name is Stifler and I'm the one that is going to be helping you with all this content on mathematics and physical sciences. I hope we are going to have a great time, and I also hope that you are going to subscribe and follow our content. So we did a couple of content on trigonometry grade 12, which we did compound angles. So now we are on double angles. So at first I'm going to prove all the double angles, and then from then we can proceed on how to use these double angles. Let's enjoy this. So we are going to use the compound angles to prove the double angles. So the compound angles that we are going to use, it is sine of theta plus beta, and we are also going to use, so sine of theta plus beta, we know that is equals to sine theta cos beta plus cos theta sine beta, and we're also going to use cos of theta plus beta, the same as cos theta cos beta minus sin theta sin beta, right? So if you haven't watched, please go to this playlist and watch what we did on those topics, right? So first off, let's prove the sine compound, the sine double angle, which is the simple one, right? So if we're having a double angle, what are they saying by double angle? They are saying that we're having two angles representing this but the same angle, right? So for an example, if we're having sine of theta plus theta, right, which this is sine 2 theta, how are you going to work around this? So the way we work around this, if you are given sine 2 theta, it is a double angle, right? So this is equivalent to saying sine of theta plus theta, which this is, if you are using that, that would be sine theta multiplied by cos of theta, because the angle is the same, so theta and theta there, and then plus cos of theta sine of theta, right? But you can see that these two are repeating the same way, right? So this will be equivalent to say this will be the same as 2 sin theta cos theta. So this is our first double angle that we're going to be using, right? So let's just copy there. So it means that sin 2 theta is equivalent to 2 sin theta cos theta, like that. So now let's move to the cosine double angle. So now how do we work around if we're given a double angle of cos? For an example, cos 2 theta, right? So if you're given cos 2 theta like that, cos 2 theta has 3 of the identities that are equivalent to this. So first off, let's use what you know about this. So cos 2 theta is the same as cos of theta plus theta, right? So using the compound angle of cos, this is equivalent to cos of theta minus sine of theta sine of theta. So the second angle here, it is theta, so we're going to replace it like that. So this is equivalent to saying cos squared theta minus sine squared theta, like that. So it means that cos 2 theta is equivalent to cos squared theta minus sine squared theta, right? But we know that cos squared and sine squared, they have the identities that we dealt with in grade 11. We know that cos squared theta is equals to 1 minus sine squared theta, and as well as sine squared theta is equivalent to 1 minus cos squared theta. So we can also expand this in terms of grade 11 work. So this is the first one. So on the second one, maybe we can change cos to be the same as that. So cos, as we said, this would be equivalent to 1 minus sine squared theta, then minus sine squared theta. So this is the same as 1 minus sine squared theta minus sine squared theta, which this would be 1 minus 2 sine squared theta, like that. So it will also mean that cos 2 theta is also equivalent to 1 minus 2 sine squared theta. But if we continue and use again this one to change sign, so this is the third identity. So this will be cos squared theta minus, and you can replace it with this one of sine, which is 1 minus sine squared, 1 minus cos squared theta. 1 minus cos squared theta. So let me just rewrite it nicely. 1 minus cos squared theta. So this will mean that this is equivalent to cos squared theta minus 1 plus cos squared theta, which this will be equivalent to 2 cos squared theta minus 1. So this is the third identity of cos 2 theta. So that is 2 cos squared theta minus 1. So depending on what you are given and depending on what you are trying to prove, depending on what you are trying to solve, you can use any of these to replace cos 2 theta, or when you are given something like this, you can change it back to cos 2 theta, depending on the situation that you are having, right? So now we are going to see how this work on a question. So I put down 5 different types of questions that we are going to solve using the double angles. So the double angle of sine and the double angle of cos. So let's see how this one goes, right? So the double angles, I'll just copy them on the side so that we can be checking while working with this. So let's see this question that we're having on simplification, right? So we're given that we must simplify 2 sine x cos x over 2 cos squared x minus 1. So on simplifying this, already we know that this is a double angle of sine there, right? So we can change it back into sine 2 theta. So this will be sine 2 theta all over. And this we can see already that this is a double angle of cos, this one. So we can change it back into cos 2 theta. So that's over cos 2, so that's x. We are using x, or x and x there. So we know that sine over cos of the same angle, they give us tan. So this will be equivalent to tan 2x, like that. We've simplified fully like that. So let's see on the second question what do we have and how we can solve that. So on this one, we are given that if sine 20 degrees is equal to a, find the following in terms of a. I already explained in the previous ones that if we're having a situation like this, we have to draw a diagram, and this is more like a over 1. So we can draw our cute triangle like that. So we're given 20 there, so this is 20 degrees, and that will be our 90. So obviously this will make this 70 degrees like that, right? So that's a 70 degrees. And we're given that sine 20 is equal to a over 1. And we know that our sine of theta is equal to opposite. So this will be our opposite, and this will be our hypotenuse. So 1 is our hypotenuse and A is our opposite. So opposite to 20, we have A, and our hypotenuse will be 1. So what's left is to find the value of the adjacent. So again, you can say our x squared plus our y squared is equal to our r squared. So this x squared plus a squared will be equal to 1. So our x squared will be equivalent to 1 minus a squared, which will be our x, will be equivalent to the root of 1 minus a squared. So here it will be the root of 1 minus a squared, like that. Like that, right? So now let's solve the following now. So sine 160, we can see that this sine 160 is way over. So it means that we need to reduce this. So this is equivalent to sine of 180 minus 20, and this falls in the second quadrant, so it will be positive sine of 20. So sine of 20 already, they gave us that is equals to A. So this is A, like that. So now we move to the next. They said cos of 70. So cos of 70, we look here. Fortunately, we have this 70. So 70 here, it will be adjacent over hypotenuse. So that's A over 1, which is simply A, like that. And we move to tan of 200, which again we can reduce by saying tan of 180 plus 20, which is tan of 20. And this is in the what? This is in the third quadrant. So cos is, tan is positive, like that. So lastly, when we are here, what is tan? Tan is adjacent. It's opposite of adjacent. So this will be just A over the root of 1 minus A squared. So now they said sine of 40, and we don't have 40 anywhere there on that triangle. So we can use the double angle of tan, of sine, I mean, sorry. So what is the double angle of sine? What does it say? So the double angle of sine says this is sine of 20 plus 20. So this will be equivalent, to 2 sine 20 cos 20. So this will be 2, and sine of 20 already we know that this is A, and cos of 20 it will be adjacent over hypotenuse. So that's root of 1 minus A squared all over 1. So this will be 2A, the root of 1 minus A squared, like that. So this will be our answer. So we need to see the relationship between the angle that you are given and the angles that you are having there. So once you can notice the relationship, it means that you can work with that, right? So I'll just rubber off some of this stuff, and you can continue with number E. We don't have F. So the F1 was saying 1 minus 2 sine squared 35. So let's just rubber off some of the stuff, and then we can work on F to H. So on number E, we are having 4 sine 10 cos 10. So how can we deal with this one? We can see that this is having sine cos, right? So it must be a sine double angle, but now we are having 4. So how do we deal with this one now? And 10 plus 10 gives us 20. So this should be a double angle of sine. So now we can factor out the 2. So if we factor out 2, it will remain as 2 sine 10 cos of 10. So that will make this the same as 2. It will be 2 sine 2 multiplied by 10. So this is equivalent to 2 sine of 20. And sine of 20 already, we saw that sine of 20 is a. So that will be, so our answer will be 2a, like that. So now let's move to this one, number F. So number F is saying 1 minus 2 sine squared 35. So how do we deal with this one now? We can clearly see that this is a double angle of cos, right? So it is saying 35. So this is equivalent to cos of 2 multiplied by 35. So this is cos of 70, like that. So what is cos of 70? When you add cos, it is adjacent over hypotenuse, so that's just a, like that. And let's move to number G before we move to number H. So number G is saying sine of 80, right? So when you are having something like this on a question, is saying sine of 80, you just try to check which angles are you having. We're having 70 and we're having 20. Can we make it 70 plus 10? But if we make it 70 plus 10, it means that 10 we cannot be able to work with. Can we make it 60 plus 20? Yes. If we make it 60 plus 20, we know that 60 is a special angle, and we know that 20, we are having it there. So this we can make it sine of 60 plus 20. Now we can use the compound angle of sine, which the compound angle of sine says sine of 60 cos of 20 plus cos of 60 and then sine of 20. So this will be equivalent to sine of 60 is root of 3 over 2, and then cos of 20 there, we said cos of 20 is adjacent over hypotenuse, so that's just the root of 1 minus a squared over 1 plus cos of 60, which is half, and sine of 20, which is a. So lastly, we can just now simplify this. So this will be the root of 3 multiplied by 1 minus a squared all over 2 plus a over 2, and you can simplify that further, right? Yes, so that's how we can deal with number G. So now let's move to number H, and let's see how we can work on that. So now number H, it is saying cos of 50. So again, how can we make this? So obviously we can use the special angle, right? So we know that cos of 50 is equivalent to cos of 30 plus 20. So we know the compound angle of cos, so this will be cos of 30 cos of 20 minus sine of 30 sine of 20. And cos of 30, it is root of 3 over 2. Cos of 20, it is equivalent to root of 1 minus a squared all over 1. And sine of 30 is half, and sine of 20, it is a. And you can simplify that as the root of 3 multiplied by 1 minus a squared all over 2 minus a over 2, and that will be our answer, like that. I hope you are still enjoying this. So let's go to the last 3 questions, and you can call it a day. So now they said you must prove that. So the last 3 questions are on proving, right? So how can we deal with this one? you have to prove that this is equivalent to that. So which one is the complex side? So I know most of you say this is the complex side, but no, it's not the complex side, right? Because this side is having singular angles. Can you see x and x? But this one is having more than a single angle. So this one is having sin 3x. So that is the most complex side. So just likewise, you are going to choose the left hand side, which will be equivalent to sine of 3x. So what do you do? What you do on these ones, you try to check what's on your answer. So on our answer, we're having mostly sine, right? So it means that we must change everything into sine. So how can you deal with this one? This is equivalent to sine of 2x plus x. So now we use the compound angle that will make this sine 2x cos x plus cos of 2x sine of x. What's next? This we can see that it is a double angle of sine, which requires that. So we can change that straight away into 2 sine x cos x being multiplied by cos x, like that, right? So the next thing that we do now, we need to change this into a double angle of cos. But the double angle of cos, we're having cos sine, and this one is only having sine. So we must change that into sine. Since our answer, we can see that it is having only the sine. So this is equivalent to 1 minus 2 sine squared x multiplied by sine x. So this will be equivalent. So this is multiplying everything. So this is 2 sine x multiplied by cos squared x plus, so this is multiplying everything inside the bracket. So this multiplied by that, that's a sine of x, and this multiplied by that, that's minus 2 sine cubed x. So now we need to get rid of this cos squared x. But from the compound, from the identities in grade 11, we know that this is equivalent to 1 minus sine squared x. So we can replace that. So this is 2 sine x 1 minus sine squared x, like that, right? So plus sine x minus 2 sine cubed x. So now this is multiplying again everything inside the bracket. So this multiplied by 1, it will just give us 2 sine x, and this multiplied by that, that's minus 2 sine cubed x plus sine x minus 2 sine cubed x. So now we can group the like terms. So this plus that, that's 3 sine x, and this and that will give us negative 4 sine cubed x, which is equivalent to the right hand side, like that. Easy, right? Yes, very easy. You just follow the rules and you apply the basic rules, and also checking what do you need to achieve, like that. So now let's move on to the next question. So how can we prove this? So obviously the left hand side is complex. So the left hand side, it will be equivalent to what? So our left hand side is equivalent to that. You can see that this is a fraction. So fractions are subtracting each other, and you know that you have to take the common denominator, which will be sine x cos x. So now sine x into this, sine and sine will cancel, and you'll be left with cos x. So cos x multiplied by that, that will be sine 3x multiplied by cos x minus, and this into this, cos and cos will cancel, so that will be cos 3x multiplied by sine x, like that. So the next step now we can see that this is a compound angle of sine, sine, cos, cosine. Can you see that? So this would be just sine 3x, and this term is minus, so minus x all over sine x cos x. So sine 3x minus x is equivalent to sine 2x over sine x cos x. But this double angle of sine, you can see what it gives us. So this is equivalent to 2 sine x cos x all over sine x cos x, which that will cancel, and you're going to be remaining with 2, which is equal to the right hand side. As simple as that. So let's go to the final question. So lastly, we are here. We are required to prove that, right? So just like the previous one, you can see that this is the complex side. So just take this side. So again, on our left hand side, as you can see, we are having 2 fractions again, right? So we can do what? We can find the common denominator like that. So what can we do next? So now this into that will be left with cos. So this will be cos 3x cos x. So this will multiply that, plus this into that, we're going to be remaining with sine. So sine 3x multiplied by sine x, right? So this will be equivalent. So now we can use the compound angle of cos, because it is saying cos cos sine sine. So that will be cos 3x. Since there's plus there, that will be a minus all over sine x cos x. So if you haven't watched the compound angles and how they work, you can get into this playlist and you can watch, right? Because we did this on the previous work. So this obviously will be equivalent to cos 2x over sine x cos x. So cos 2x, it is equivalent to that. So that's equivalent to cos squared x minus sine squared x all over sine x cos x. And now we can see that this is the difference between 2 squares, right? Because this is saying cos squared x minus sine squared x. So this will be equivalent to cos x plus sine x cos x minus sine x all over sine x cos x, which is equal to the right hand side. So that's how we can use the double angles. I hope you enjoyed this session with me. I really enjoyed this session. So please don't forget to subscribe. Before you can exit this video, please rush to subscribe, since subscribing helps us a lot. When the family grows, also our potential grows, right? So I will see you on the next one, where we can combine the double angles, the compound angles, and also doing a lot. And mostly I want to focus on dealing with general solutions, right? So until then, I'll see you on the next one. Have a great day.